Welcome back. In Part 1, we talked about the birth and growth of tropical cyclones. If you have not watched Part 1, please go to the link in the description. In Part 2, we will discuss the journey of tropical cyclones across the ocean, their impact on the regions they affect, and the science behind forecasting their track and strength. Let's begin. We will talk about the track of a tropical cyclone and how they move and dissipate. Once a tropical cyclone has developed in the Pacific Ocean, it typically heads westward. During its journey across the ocean, it gathers more strength and water content due to the energy it absorbs. This makes it more powerful. However, a tropical cyclone will start to weaken under two conditions. The first one is when it encounters cooler waters, which cut off its heat source. And secondly, when it makes landfall, the continuous access to moist air stops, and the land's friction reduces the wind's power. As a tropical cyclone begins to lose the energy that powers its force, it becomes weaker and eventually dissipates, which means disappears. We will explain the weather of the region affected by tropical cyclones. Before a tropical cyclone arrives, the weather often feels very hot and uncomfortable. This happens because, near the center of the storm, there is a lot of upward moving air caused by strong convection. When this air climbs to the top of the lower part of the atmosphere, it can't go up any further and starts to move out to the sides, then falls in the areas around the tropical cyclone. As this air comes down, it gets compressed and heats up, which makes the temperature in Hong Kong go up. As it comes closer, the wind speed increases. This is because the tropical cyclone has a steep pressure gradient which causes high wind speed. The wind speed is the highest in the eye wall. When the eye wall of the tropical cyclone is closest to a region, that place will have a great wind speed. The air pressure will be lowered too. Why? Remember, a tropical cyclone is an intense low-pressure system. The eye at the center has the lowest pressure. It is often below 990 hectopascals. As tropical cyclones come closer, air pressure reduces. When the vortex is very near, the air pressure drops further, and the wind speed becomes much higher. Rain may fall and cause a drop in air temperature. After the tropical cyclone leaves, air pressure rises again and wind speed decreases. Here in Hong Kong, we're no strangers to these tropical cyclones. They can bring heavy rains, fierce winds, and sometimes devastating consequences. Storm surges are one of the greatest threats that tropical cyclones can bring to Hong Kong. Storm surges often cause serious damage to the coastal areas. The strong winds of the tropical cyclone can pile up the seawater near the coast, while the low air pressure of the storm also uplifts the sea surface on its path. Both factors cause a rise in the sea level, which is enough to flood low-lying areas. Finally, we will talk about how we can predict the track and intensity of tropical cyclones. Predicting the path and impact of tropical cyclones is a complex dance of technology and science. It starts with satellites, watching from space, tracking every move of the storm. This data feeds into what we call numerical weather prediction models, or NWP for short. These models simulate the atmosphere's behavior, crunching numbers to predict where a cyclone might go and how strong it might become. But there's a new player. Machine learning models are changing the game. These computer programs learn from past storms to improve future forecasts. Over time, ML models are getting better at predicting not just the path, but also the intensity of these storms, a crucial factor for emergency preparation. Among these tools is the Pangu-Weather Model, a prime example of the machine learning models employed by the Hong Kong Observatory to predict the track and intensity of tropical cyclones. The Pangu-Weather Model is a proof of the power of artificial intelligence in weather forecasting. By inputting through huge volumes of data, this model discerns patterns and anomalies that escape the human eye. It examines historical weather patterns and current atmospheric conditions. It uses complicated algorithms to simulate the future movements of these unpredictable tropical cyclones. At the Hong Kong Observatory, meteorologists are armed with the insights rendered by the Pangu-Weather Model. Taking the opportunity of AI development, the observatory introduced the Pangu model in mid-year 2023 and started running the model for weather forecasting on a trial basis by making use of AI and big data technology. In recent years, meteorologists have begun to try applying machine learning to make up for the shortcomings in forecasting of tropical cyclones. Through artificial intelligence, meteorologists hope to uncover clues that will provide answers to these questions, like how the internal structure of tropical cyclones affects intensity changes and how these structure changes should be quantified. The future of forecasting is bright with promise. As our computational power grows, so does our ability to predict and prepare for tropical cyclones. We are harnessing big data, artificial intelligence, and ever more sophisticated modeling techniques to look further ahead with greater accuracy. The goal is not just to forecast the storm, but to anticipate its impacts, guiding actionable intelligence that can save lives and livelihoods. We still have a long journey in predicting tropical cyclones, and we will move closer to harmony with these mighty forces of nature. That's all for this video series. If you would like to learn more about tropical cyclones, please take a look at the link in the description, where more details on tropical cyclones will be discussed. Also, we invite you to complete the post-video survey after watching this series of videos. You may follow the link provided or scan the QR code displayed on the screen. Thank you for joining us.